Good afternoon. Thank you very much for being here to give me the opportunity to explain also our background in fusion for IDOM. We also have a point of view very clear of the fusion opportunities in the future. First of all, we consider that fusion is, let me say, a clear opportunity in the future to solve one of the most challenging problems we have with the carbon dioxide emissions, as we have explained here in several explanations. Okay. From our point of view, we have been involved since 2008. So we have a background of contribution to the fusion project, specifically 147 fusion projects, basically in ITER, but also at the beginning in Tecnofusion with CIEMAT, also with collaborations with UNED, with neutronic analysis and so on. And we are right now even, we have a real presence on site in Cadarache with a team more or less of 20 people developing support to the owner activities. That it does means that we are helping to construction of the site. And more or less the last, our last contribution is one huge project, which is the key turn project for the leak detection system activities, and we are working on it right now. More or less our capabilities are, we are 50 engineers working continuously on this kind of projects. And of course, my main purpose is to try to convince you, of course, to focus on fusion activities and fusion projects. If you have this knowledge and you want to develop your career opportunity, and of course, IDOM is open to help you whenever you consider trying to participate in real projects and to close as much as possible fusion activities in your daily, in your future work. That's our basic main purpose in this conference. Okay. On the other side, we consider that that the main objective of our companies is try to demonstrate not only the theoretical activities, but also the reality, trying to put on the table and to convert the project.
Well, I'm very much worried. I will not say very much, but I worry because I mean, we are focusing on fusion, okay? But for example, people like me working on material science, I mean, we have a lot of things to say in different areas, okay? So the solutions proposed for fusion, they are sometimes transversal solutions for any other energy sources, okay? So for example, when dealing about corrosion barriers, we have the thermosolar, and we have molten salt in fission generation for, and so on. So do you have someone in the industry looking at this transversality in the technologies, okay, which can be applied for fusion or for any other technology? Or should we do it as the research? I mean, who is going to take this action? Okay, is the industry going to take care of those activities, or should we do it? It is not clear for me at the right moment. So these could be my two questions. Thank you.
Yeah, okay. Well, you like to answer or myself? Or?
I can give my point of view. Mm-hmm. Of course, from my point of view, it's responsibility from both sides. I mean, one of the parties is the responsibility of our companies, and we should invest in these kind of things. Of course, it's not easy, let me say, because our way of doing is try to do this kind of interesting projects, of course, and to get profit. Okay, that's the reality. Mm-hmm. But on the other side, we should do this, for example, investing in doctorates and in scholarships. We do it and try to get this kind of capabilities with this, let me say, initial value when you finish your studies or you want to detail this kind of investment activities, and we should invest, and we do it, in fact. So I think, from my point of view, it's a double answer. Of course, we have to take care about this, and I'm sure that if we take care and we do it, finally we take the profit in the future, because we will have more prepared capabilities in this kind of things, develop this kind of activities, and of course to include it in future projects. So that's my point of view, and we will do it, and we are doing it.
Does any one of you want to add something about her question on the transferability of our results to any other field except fusion technologies?
Yes, regarding the previous question, I probably like to add something just to see what are the industry working. For each specific contract, for example, in the case of the first one, of course the industry, and I think in this regard it is important the effort of Fusion for Energy and also ITER organization to define certain limitation in the contracts, because of course we are assuming certain risk, but always the contractual approach is in such a way that we have this limitation of liabilities. There is another aspect also regarding the first question. What is really important, and I think this is very important in Spain, is the integration of the research with the industry. I think this is an example, and I thank Manuel, because I think we are participating in several forums, and they are thinking on Spain, why Spain is so successful in fusion. And I think, to me, probably is the first time and the unique time when, from the very beginning, we have been collaborating, the university, CMAT, CEDETI, that the Spanish industry is integrated with the research in such a way that we are working together in certain way. Of course, we have our independent strategy, but of course, for example, after this talk, this afternoon, I have ideas on certain things that we can do together. I think this is an important element. And the second question about the synergies. You know that in Empresarios Agrupados we are working in fusion, in advanced reactors, generation 4. We are supporting the nuclear power plants in Spain. We are working in wind technologies, in solar technologies, all the spectrum mainly in the field of energy. Okay? I can say you that, as we mentioned, the heat exchanger of the first wall panels for the demo, the balance of plant have certain ideas on how you can transfer the pulse energy to a state. And for this storage, you can use molten salts, that is very common in solar technology. Means that, of course, our experience, and probably is the added value that we have, is to see these synergies that are more than expected. Of course, there are synergies on the nuclear, but also there are synergies in the conventional, renewables, and all the technologies. That yes, the answer is yes, and I think probably is the value of the industry to make this realization with the soft transfer of the knowledge from one technology to the other.
Totally agree. Just one additional comment regarding technology transfer. For example, in EDOM, we are doing also development for small modular reactors with molten salts. Okay, and this is a clear example to make this kind of transfer technology between fusion studies and fission studies with new generations reactors. Okay, and of course we are doing it, and we should do not only in this stage but in other technical areas. So totally agree. Yeah.
Sí. Okay.
I think that maybe for our students can be of interest to know how many jobs can your companies take in the, let me say, in long term, in short term or medium term, just to work in fusion, just to know how can be the opportunities, just to work in your companies in fusion, and just to have, let me say, a rough number.
A rough number. But basically, for example, from our side, from IDOM, we are talking about, in business numbers, 6 million euros per year. That means, more or less, that we should maintain our team of 50 people working in this kind of projects, okay? So we will say, more or less, a team of 50 people and growing more or less in 20% per year. The key point here is not, let me say, the amount, but also the kind of projects that are related to fusion activities. And from our understanding, it's not only ITER, but also is the future demo, is Ifnizones, which we consider very interesting, of course, for being in Granada also, but also other fusion reactors, like STEP in UKA, and other incoming startups around the world that are betting for its own technology. We consider this another key point from the future, and we are working in our strategy to go forward these and other opportunities.
In empresarios, we have revenues of about 50 million per year. We have 120 engineers working on fusion, and now in the last 2 or 3 months, we have incorporated a new assignment of about 20 more engineers in the last 2 or 3 months, precisely for the first wall panels and the contract for installation of the safety pipes in ITER. Is why I say congratulations, because I think now fusion will incorporate a lot of new jobs for engineers.
Well, maybe I made one. I want to make one question to Dimitri, one to Joaquin, one to Connor.
Perfect.
Yes, Dimitri, you have been involved in many different projects in lasers, and in the last time you have been involved in so great as PETAL, LMJ connection, LMJ PETAL. So in this kind of, in this field, in France, in particular, in your experience, how is the link in between industries, engineering groups, and research facilities to be developed?
Well, I think that is working, yes. Before answering your question, I think that it must be clear that the situation for inertial fusion is different from the situation of magnetic fusion today, because this is partly because in no European country there is a project for inertial fusion for the production of energy. So this has not slowed down the basic research, but it has slowed down the technological research. Of course, there is a lot of connection with industry, because you build a facility, so you need to have the lasers, you need to have the vacuum system, you need to have the diagnostic, you need to have the electronics, you need to have the buildings. It is more like a collaboration work with the industries that are working in these fields, which is not just involving inertial fusion. You know, for instance, in the field of laser, which is maybe the most directly connected, in Europe there is an explosion of laser facilities today. I would even say maybe even too much. You know, we have Apollon and PETAL in France, we have the 3 LI, extreme light infrastructure in Romania, Czech Republic, and Hungary. We have the CLPU in Salamanca, which is working very well. Maybe it's the first petawatt system in Europe, which is really working at high repetition frequency. But, I mean, it's very good, but it also poses some problem due to the dimension of the community. The market of laser is dominated by a few companies, in particular Thales in France, Amplitude, again, a French company. I mean, there are not more than 3-4 companies which are, and when you build a facility like this, it is always a collaboration work between the facility, between the company and the researcher of CA or of other research agency who build the facility. In France, I would say something which maybe sounds very bad.
For Spain.
The market is a bit doped by the fact that the main funding is coming from the Ministry of Defense. This puts severe limitation on the choice of industries, on the interaction that you have on the exchange of information. I know many researchers think it's good we take the money from the military, we do the research. I'm not of this opinion. I think that in a way the military environment is restricting the exchange of information, it is restricting the progress. And this is also related to the relationship with the industries. There are not many companies. I mean, in the PETAL project, maybe we got 10 companies developing diagnostics, which are, I mean, small, medium enterprises working on advanced technologies. Again, the relation was quite good. The point is that these are more like one-shot enterprise. I mean, not one. You do one PETAL. I mean, so I don't know. This is my answer to your question. I just wanted to add something else related to the transfer of technology. I think that luckily the research of inertial confinement fusion has brought some good possibility of spin-off concerning laser-driven sources of radiation and particles. And I think that this technology is now mature for industrial application. We can make really high brightness X-ray sources, proton sources, neutron sources, and this can be also very good for the studies of material for magnetic fusion, because of course in a plasma you generate X-rays and protons and electrons and gamma and everything. So, and you can do this with laser-driven X-ray laser-driven sources nowadays.
Yes, now they talk to
Okay, no.
him.
I wanted to make a comment. Make it your comment. Make your comment and I make it.
No, this was, you were asking at the very beginning whether the Spanish industry is competitive, and I can tell you it is. I mean, Carlos yesterday was showing very quickly a diagram where it says Spain is the third European supplier of ITER. In 2020 it was the second European supplier of ITER cataracts, the third of ITER through FUSIÓN for Energy in Barcelona, and the accumulated budget awarded to Spanish companies, I think this is from 2008, is nearly 1 billion from FUSIÓN for Energy. So it's and it is something like 100, maybe 80 to 100 companies are involved. Of course, the big ones are the ones we have here, plus Ferrovial, plus a few more, yeah, Sener, we are also working. And doing not only the buildings, which by the way are extremely demanding buildings, not just conventional ones, yeah, and doing engineering in many areas. I mean, Idom is working on the blankets that David Rapizarda was showing yesterday. They were working on this. Empresarios is working on the first wall panels. So it's not only engineering. We have very good engineers, but they are taking real challenges towards absolutely new technologies. So I think the Spanish industry is in a very, very good position in fusion. I don't know what was different to other areas. I think they are also becoming competitive in other areas, but this was not the case when we started. I mean, when we started, the largest industrial contract of a Spanish company in the big science projects was the supply of energy to the synchrotron in Grenoble by a subsidiary company of Endesa. So not much more, yeah.
So then it's worthy to invest in fusion and then to work for the for the companies working for fusion.
Well, that was my question. You advanced my question. So thank you, Joaquin. That was my question, which is the competition. Yes, I want to make a question to Connor. Well, our friend in IDOM talk about Spark. That is a private initiative together with MIT. There are other initiatives in the world. In particular, in inertial fusion, we have several initiatives. And we hear yesterday another initiative, which is Innovan Energy, starting with disruptive ideas. We will see what's happened, but it's a new. So IDOM and empresarios maybe wants to invest in Innovan Energy. So, but in any case, my question to you, Connor, is maybe you can say to us which are your plans in technology, which are your vision now.
Okay, our vision, yes. Does this work? Yeah. So right now we're essentially just getting started, looking to expand. We've spent the last 10 years as a small group working on our laser technology and ideas, like I presented yesterday, doing lots of calculations, filing patents. And a lot of the technology was built on work demonstrated by our team in prior decades. So it's built on a lot of experiments, one of which I discussed with you yesterday. And so now we're at the point where we want to build out the architecture and demonstrate it. As you might remember from yesterday, the key new innovation is this SBS pulse compression, very high temporal ratio and atmospheric pressure gas. And so we're looking for funding to build a demonstration laser, relatively small scale relative to an ignition facility, to prove this physics, to prove amplification after imaging, to validate that. At the same time, we're working with the Laboratory for Laser Energetics. We're planning a series of target shots on the Omega laser to help add confidence that we can get ignition with their higher adiabat, lower compression targets with the type of illumination geometry that the Aspen architecture can deliver, and to de-risk some LPI elements. So those are the next steps, is we're seeking funding from industry, from investment, from government to do that. Our long-term plans, of course, are we think we can demonstrate ignition in 5 to 6 years using the Aspen architecture, assuming those first steps check out, the demo laser, the shots in Omega, potentially some shots on NIF. If all that checks out, we think we can get ignition by going to 10 to 20 megajoules to ensure confidence on the 5 to 6 year time frame for under $350 million. And that comes from the dramatic cost reduction in our laser architecture compared to NIF, because we essentially have no glass, no expensive glass in the system. That also increases makes the development time faster for building out the system, because we KRF gas at atmospheric pressure, and all the pulse compression apparatuses are all atmospheric pressure gas. There's no delicate system components like there are in the glass architecture. So we think that the development time will be faster. So, and of course, as we proceed, there'll be a lot of exciting things. Having 10 to 20 megajoules on target, you can imagine all the different things. Opens up a lot of different target design possibilities, like the hybrid target that Mike Campbell mentioned of doing first an indirect drive pulse and then a direct drive pulse. So there's all combinations, direct drive, indirect drive, hybrid. We believe there's a big design space that's opened up by going up in laser energy and up in adiabat and fielding lower compression implosions. So.
May I make a comment?
Yes.
Yes, a comment about those private initiatives towards fusion. A word of warning. Yeah? At least in the magnetic field, we are used to learn about proposals, which say, "Oh, look, this is much simpler than ITER. It costs 1/20th of ITER. It will go much faster." And then what you are explained essentially is a concept of confinement. Yeah? Then if you go to ITER 25, maybe 30 billions, how much do the vacuum vessel of ITER cost? 400 millions, maybe 500, out of 25 billions. How much do the TF coils, the big TF coils cost? All the TF coils will cost $750 million. Now you have the vacuum vessel and the coils. Add the horizontal coils, maybe another $500 million. Vacuum vessels and ITER coils, not even 2 billions. What is from 2 to 25? Buildings, heating systems, cooling systems, tritium systems, and so on, and so on, and so on, and so on. Time and money, which you need nearly in every system. So be careful.
Very good. Good answer.
Actually, I want to follow your comment because in inertial fusion, from time to time we see flourishing of companies which are promising fusion for tomorrow. And I'm really surprised that they can get money because they raise money from private venture capitalists and I think that this indeed in the end it goes against the benefit of the research of nuclear fusion. It really, I mean, the politician, part of the public opinion says, okay, you have been promising nuclear fusion for the next 20 years, since 80 years. But adding now fake companies which promise fusion for tomorrow will make the situation even worse. Actually, I was very pleased to listen about Innovea yesterday because this is a serious company which is making serious research. But I mean, there are companies, today we were speaking about Marvel Fusion. I think that Marvel Fusion is on the edge of promising fusion which will never be fulfilled. There are companies in the United States, I don't know. I don't want to be too negative about things which I really don't know too well. But for instance, 3-alpha company, I mean, you never know what it is inside the machine. I mean, they just make publicity, but you know, like the publicity of hamburger, where is the meat? You know, so.
So come on, who is interested to express something or to ask the others, the professionals about fusion? Are any of you following a master or a doctorate in fusion where you, Manolo?
Master degree. Master de masters.
Manuel, you are starting.
If not, do any of the members of the roundtable wants to ask something to the students in particular? Something that you think they must must know, or they must, yeah.
I want to question to the engineering groups if they want to make a contract to me.
For sure. For sure.
Too expensive, Manolo.
I know.
Too expensive.
I know that here there are students which are out from outside Europe. So, you as a person who come from, I mean, nuclear fusion is usually considered, it is a business of Europe, United States, China, okay, Japan. So, as a student who is coming from outside of this country, what is your perspective towards nuclear fusion?
Perspective to work in nuclear fusions, in fusion.
Well, Elena worked
Elena.
in fusion.
Elena, yes.
Well.
Okay, hello. So, yes, I actually work with María Teresa in Empresarios Agrupados. And actually I started in the Polytechnical University working with Manolo, so he knows me well. And well, what I can recommend the people that is thinking about a career in fusion or in all this kind of advanced research projects is you have to choose your path, taking into account what may interest you, even though it's never a straight line. So I have been outside Spain working in research installation like CERN, and then I went to France, and then I came back to Spain. And I actually, when I finished working at CERN, I thought I would not have such a close relationship with research again, but fortunately now we are working for ITER, so we have the opportunity to come back to research. So I would encourage everyone that thinks that is interested in all this kind of projects to really search for opportunities, because there are many more that you can think, not always in the same exact way that you think of them. But if you like something and you are interested, you should try to search and to see what the possibilities are. So I really think it's a really fulfilling career if you like to research, and I would encourage people to search, to go to this kind of conferences, to meet people in the industry, to search a little bit in the news for new opportunities, for new research projects. I think it's really enriching for a career. I imagine there's maybe someone else that is working that wants to answer.
Thank you, Elena. It's a very good, it's a very good thing. Okay.
I heard a lot about engineering in these speeches, but I'm finishing my degree in physics, and I would like to know which are the jobs or what can I do for fusion.
So the possibilities the young people have to work in fusion.
Just a very quick comment. Right now, currently, maybe it's for 10 more days, we have 4 positions open for PhD students in our lab. You need to have a master. Yeah, it's the only requirement.
See, to highlight this, one is in particular related with Technofusion, is supported by Technofusion, so be aware of the web pages for the Community de Madrid and CIEMAT.
Yeah.
From our side, from IDOM, it's really easy. You can go to the web page and you can see our activity. It's a clear state to send your CV, and we come back to you to see how is your interest, because we have a lot of different projects, and to try to find out the best matching between your interest and the actual status of the project, which we think it's very, very important, because we can not propose you anything you not consider interesting for you, because we consider this the key point for the success of the activities. So I encourage you to go to the webpage and to enroll. Okay?
Teresa?
In Empresarios is the same. Of course, you can send your CV and we can consider that for certain projects, but also we have a process for starting after the career. We can propose some projects for the mastering, and we pay a lot of attention to that. Means that we have the full range of possibilities. You have already finished and you like to work in the projects, or you like to do your master. Means that, and now it is the moment we are really looking for new CVs for the new contracts. Means that it's a real option now.
Just one clarification. I don't know if we can share with the students also our email address directly. If you can send directly to us your CV, we will appreciate it. We will study very carefully. No problem. Apart from the webpage, of course. If you can share our.
Is there any opportunity in convent in Noven?
Well,
any opportunity for the Spanish students, I mean?
Yes, we're hoping to collaborate with the universities here, especially on the high life chamber design. Because of course, ignition is not fusion power. It's just demonstrating gain of one in a target. And so after ignition is achieved, it's a whole other level to build an IFE reactor. But we believe the high life, thick molten fluid flowing chamber is a good way to go, and there's still a lot of research to be done in that area, and so we hope to collaborate.
And what is the case, Dimitri, for the European project you are leading? Is there in the next 4 years any student offer to join the project?
Well, actually, the Eurofusion project in reality gives little money. I mean, there are other projects. There is possibility to get directly some PhD grants from Eurofusion, but let's say this is more the business of the universities which are belonging to the network. In principle, it is always possible for Spanish students. We already had several Spanish students in my laboratory, for instance, and also in the other laboratory in UK. And unfortunately, for our laboratory, we have severe limitation for getting the student from outside Europe, and this is again because of the links with the military funding. And I think that this is really a pity, because I know that in China, in India, there are bright students today. So we are fighting every day to try to win the limitation, but the limitations are still there.
Okay. Unfortunately, we are run out of time. So if you want to end the school, I'm not going to do that. I only the leading of the round table today.
The personnel of the organization are here. I want to thank Manuel Lopez Pleite and Elena Riero, who are the two really persons that make everything for having this course being successful. So I want to thank now that they are here for his effort and her effort, and please an applause for them.